Okay. Yeah. Thank you for that. Once again, guys, welcome to today's session. Uh, I'll be your first facilitator. So I'll be taking you through this first part of it, which means we're gonna be covering some bit of theory around what network security is. And yeah, so Lisa, if you don't mind, let me just share my screen. Awesome. Yeah, so once again, like I said, my name is Alex Moura, and I am a SOC analyst. And the word SOC means Security Operations Center Analyst and a technical mentor at Moringa School. So I'm not only a cybersecurity technical mentor, I also do uh, offer mentorship services around software development, mainly on front-end development using React. Yeah, basically I'm a jack of all trade, but I would like to call myself as a person on a path to learn new things every day, and there's really never enough to learn, especially if you work in tech. So yes, this is Licio, but we'll be hearing more from him when we get to the practical side of things. So I like to imagine him as our in-house hacker. He's really experienced in a lot of things. So yeah, let's build up to what he's going to be teaching us later on the day. Our agendas for today are as follows. We're going to be talking about computer networking, some network transmissions, now the network communication and security, mainly on a focus of the OSI model, what happens there, the different protocols that are involved there, different attacks that are there, and yeah, so on, so on. And finally, then we're going to have the second part, which is now the network and protocol analysis part of things, where we're going to be installing some few tools, Wireshark being one of them. We're going to also interact with some few command line tools there and some GUI elements to just wrap things up. And finally, we're going to have like a fun activity for all of us to try and do. So it's going to be capture the flag. So ideally, I don't know if Sasha is going to reward the winner, but we'll organize around that. And yeah, we're going to invite Sasha for our final Q&A. So yeah, I hope everybody is ready to begin the session. So do give a thumbs up if you're an attentive student, and I can begin. So yeah, normally for a session like this, we'll begin asking ourselves, what do we mean when we say network security? And I'd like to hear some few answers from some of us just to get an overview of how we understand this world of networking. So I don't know some of you, so don't hold a grudge if I just call on you. Okay, so just gonna call on you on how I see the order from my screen. So let's hear from Samson Timaz. What do you understand what network security is? Mic check, Samson. Okay. Right. So in this workshop, we're gonna be discussing about networking a lot, and it's important that we understand that it is different from networking on its own. So, but before we define what network security is, we have to break the words a little bit. So, the word network means it is a bunch of computers talking to each other to relay communication. Now, there's a problem here because we need to have a system that ensures we maintain the CIA triad, which is confidentiality, integrity, and availability in this communication. So this is where now network security is very crucial. So in terms of computer networking, it has really evolved. We have moved from analog to digital. We have seen modems evolve to routers, wired to wireless, and really networks connect computers and many other types of devices. We see cars having networks nowadays, medical equipments, appliances, and cameras. So that means that networks need to be able to support reliable and secure communications, protecting the valuable data they transmit from unauthorized disclosure. And we maintain that integrity and we ensure that we don't lose data. Like I said, in this workshop, we will describe some fundamentals of networks and how they work, because you need to know how they work in order to secure them, basically. So we're going to examine the languages that networks use to communicate. And by the end of this workshop, we hope you will have a good understanding of network operations and security. So let's get started. Once again, the definition of a network is two or more computers connected to each other. And ideally, the evolution of networking began as so. We had a crossover cable between two different systems, and this enabled them to communicate and share data, right? So that was a peer-to-peer kind of a relationship. And it later expanded, the idea expanded to what we now call a hub, where we had many devices that could share data, as we see in the diagram here. And three computers now could share data, like they could be connected to a printer. But the problem with this kind of a system was that all traffic going from one device to another was also shared to all the others. So along came the idea of a switch, right? So it was basically the same as what the hub was, but now traffic going from one device to another only went to that destination device and wasn't shared with everybody else on the network as well. So the other thing that we're going to be focusing on is network transmission, right? The first network transmission really were wired using copper to join two devices together. But then came the idea of what we now have, the coaxial cable, so which gave now like a little higher bandwidth or more traffic, right? And the idea also evolved into fiber, which greatly increased speeds of many of our networks. But also we saw the development during now this era of fiber and coaxial cable of different types of wireless, right? We had the emergency of the wireless access point, which now led to the creation of Wi-Fi. So if you do know the meaning of Wi-Fi, you can try and type it on the chat, but the idea of Wi-Fi being that now we had a wireless access point, it was able to provide access to many devices in that area. Satellite and microwave were two of the types of wireless communications that required line of sight, right? So the device that was going to communicate with a satellite or between two microwave systems had to be able to see that other destination point, rather, yeah. So that means we couldn't have things like trees or anything to obscure the line of sight. So, and during this time, we also had now the development of infrared, so which is used a lot in conferences. And so we now after establishing network transmission, now we were at a point where we could have many different types of networks, right? And some networks by their very nature are more secure than others. For example, fiber tends to be rather secure type of communications rather than satellite, because traffic can be picked up by many thousands of devices over 100 square miles, whereas fiber is just only transmitting to one medium. So now that brought around what we call the network types, right? We have the local area network type, which usually is within a small geographical area. Then we had the one where we could join different local area networks together, and so often a distance apart, right? Now the way we establish this is using maybe some type of leased line from a telecommunications carrier of some sort. So we also do have the personal area networks, and many of us are actually using this and are familiar with this. Maybe you are not aware that they're called personal area networks. For example, the AirPods that you have maybe here listening to me right now. That is some type of a personal area network which communicates via Bluetooth. And now after this, we had now what we called the internet era, right? Which is now the 1960s, where we had the emergence of things called the ARPANET, right? Which now was stolen from some scientists, yes, but the idea behind what they were doing was, remember, we were transmitting network traffic like as one, but now they broke down the packets, so we had different packets going different directions, and that now brought like some security around the traffic that we are getting, meaning that we can't lose data. And so really the internet was born. And you can have, I do have a video around that, and I'm gonna share after the presentation, and maybe you can learn what the internet is and how it was born. So, but just know it was out of this different medium of transmissions being able to handle large amount of traffic, and not only handle that, but also transmit them by ensuring availability through dividing the packets as they were transported, and later on being assembled somewhere else to make sense of that data. And it's now allowed communications all over the world, which is what we are using right now to be able to talk to each other. So the next part of this, after understanding now why the internet is important, network security, and what all these are. Then we're going to be looking at how does communication happen between different networks, right? And really, this is a field that has required a lot of thought and engineering. So it answers the question, how can we send data between two different systems and ensure that it's properly understood? So when we talk as people, right, we use analog types of communications. Our voice varies by frequency and amplitude. Frequency being the number of cycles per second, and amplitude now being like the strength of the signal, maybe how loud I speak, right? But when we talk in a computer, we are using what are known as digital signals, which means there's only two values, 1 or 0. So for the most part, if I'm going to send a million ones and zeros to a destination device in the next few seconds, right? That destination needs to know, what does that 1 mean? What does that 0 mean? And so that is why we need like some kind of model, some kind of protocols for this communication, just to dictate how this data is understood by the other destination, by the recipient, right? And the first of these protocols and models was the Open Systems Interconnect, which is developed as the international standard, right? I do hope we are clear on that. I'm not able to get a reaction from anyone, given that all our videos are turned off, but I do hope you're paying attention. So like I was saying, communication was of signals like zeros and ones. So we needed like a way to understand all this information. So we needed a common way of communicating, or rather distinguishing different patterns in those ones and zeros. And now those are the models and protocols. And one of the international standard was the ICO 7498, which is now known as the OSI model. It also had like a second part to the standard, so which addressed security into that model. So one disclaimer, we don't actually use the OSI for communication. Instead, we use it as a reference to describe how communications work. I hope that is clear. So let's take a look at that, right? There are 7 layers to this stack, as we call it, starting with the top, which is the 7th layer. So get that. So the top is the 7th layer and the bottom is the 1st layer. So the top is the application, presentation, session, transport, network, and data link and physical finally. So the application layer is used to interface. So I hope you were able to see my screen. The application layer is used to interface between the user's application and now the communication system that you're going to be using. So for example, we have an illustration here. We have a user who writes an email using some type of email application. Let's call it Gmail, right? So that user application, which is Gmail, now has the content of the text, and the user now hits send, right? So what happens is that the data is sent across to a destination device, and the data itself contains the content of the email too, right? So we're just transmitting data. So don't think about the contents that are inside the email. So think around, we're gonna be transmitting a package, rather, like the right words to use is data. And that piece of data will pass down to the application layer of the OSI stack. And the application layer, which is the first to receive, which will now send it out, right? Yeah, it is the one that sends out, will eventually gonna, just a second. So the application layer says, well, eventually this email is going to get to a destination device, and the destination device will need to know what to do with it, right? So I'll put a header like on there, then I'll say, hey, this is an email. So when it is received by the application layer at the far end, it knows to pass it to the now specific destination emails application, not to any other service like the web browser or maybe an FTP server, but only to an email application. So in this case, the header, it's the most important piece of information there. Okay, not even the content of the email. So when data gets to the application layer, the header looks at that, sees where to redirect that traffic. So that's, you can clearly see it now in this explanation here. We have a sender who sends data to the application. So it's gonna go down, and it's gonna now go out through the physical media, and the receiver is now gonna receive it through the physical media. And this is where it's gonna be directed up to the user application, but I'm gonna just be explaining this in just a minute. So this header from before here, when the user writes an email, we have a header attached to the data. So this header is not intended to any other layer here, but the application layer. So the purpose of this header, as we said, is so that the sender uses their user application to send traffic down through the application presentation, and so on, down finally to the physical layer, right? So it's gonna now traverse like across some type of physical media, and that data now reaches the receiver's machine, okay? And the receiver's machine then passes the data back up those 7 layers of the OSI stack. And of course, as we said, in order for the application layer on the receiver's machine to know what to do with it, it then reads the header that was provided by its corresponding peer. Now it will know where to direct the data in the right user application, okay? So if it is like another type of, not only if it is an email, like it was now like a file, it will not direct it to an email server, but a file transfer. If it is like a web request, it will now open a web server. I hope that is clear. So we have looked at now like traffic going over the physical media. You'll see the application header, right? That, no, in the case now where the data reaches the physical media, where this is now where you get to see the application header that indicates it's an email, and the data, the content of the email, and we can actually encrypt emails. So which would mean like we encrypt that data that's being sent by using products like PGP and sysmime, for example. So when we go down to the presentation layer, this is where we deal with things like formatting. So this is now the presentation layer. After the data has moved from the application now to the presentation layer, this is now we're gonna be dealing with things like formatting and compression. But before that, I'd like to know if there's anyone with a question. Do give a thumbs up on the chat if at least everything makes sense so far. Thank you, David. Awesome. So like I said, now, when you go down to the presentation layer, this is where we deal with things like formatting and compression. So if I'm going to compress some type of traffic to save space, then I will use the presentation layer to achieve that. So I'll put a header on there, the presentation header, right? Very important to distinguish that. That will tell the presentation layer at the far end, again, oh, by the way, this is compressed, so you need to expand it back before you give it to the application layer. Or if you won't know what to do with it, yeah, like it won't. Now, if the presentation layer doesn't know that it is compressed, then the application layer won't know what to do with that data. So it becomes meaningless. So this is also an important section. And then we have the next layer, which is the session layer, right? So this is where we log into a remote device. This is where we do session management. So if you're doing something like online banking, we put in here some type of indication which session this communication belongs to. And that means your traffic goes to your session and not to somebody else session. So that is pretty clear, I hope. And here we also see like we have a number of different protocols used, things like layer 2 tunneling protocols. So maybe you can note them down, right? But all of these things we're gonna be focusing, like we're gonna be dissecting these protocols, session management, what this means, right, in the upcoming bootcamp. So keep a lookout for that. But let's continue. But ideally they help us manage the session, all of this, the PPTP that you're seeing. So that means point-to-point tunneling, right? And we also can encrypt at this layer using things like now secure shell. Yeah, so that is now the first part of my presentation, and I'll just pause again in case anyone has a question. Okay, awesome. So I think we're gonna keep time and yeah, just dive right into the next part. This is now the lower layer of the OSI stack. So far we have talked about things like application, presentation, and session, but now we are going to actually change direction a bit and look at how do we actually format the communication to go across those wires, those, yeah, basically those physical mediums, right? And the first layer of the lower layer of the OSI model is the transport layer. And here, there are two main protocols that we normally use, and we like to call them languages, but depending from where you come from. So they are TCP and UDP. So depending on whether the protocol used is TCP or UDP, we may call our communication at this point either a packet or a stream. So if it is TCP, that is when we call it a packet. And if it is UDP, we call it a stream. So as a fun activity, maybe get to research around that too. So now in the transport layer, this is where we worry about making sure that the traffic gets all the way to the destination, especially if it is TCP, for example. So we put here like another header, you guessed it, right? We put a transport header to make sure that hopefully that traffic does get there and acknowledgement can come back. So we shall be actually visualizing this today. When we get to the practical bit of things, we shall get to inspect a TCP handshake, get to see what that really is. So, but we can just dissect that briefly. So if you looked at how TCP sets up communication, let's say we have two devices, host A and host B. Host A wants to send traffic to host B. So it sends what we call a SYN, that is to synchronize a request. Basically, it's like saying hello and a random number. In this case, I chose that 200. So host B gets that traffic, that SYN request from host A, and being very polite, it acknowledges that and sends back traffic and increments that random number up to now, that's to 3,201, but it then also sends its own SYN packet with a random number. In this case, I chose 4800. So host A will then now respond back to that request for a SYN from host B by acknowledging that it received that SYN request. This is the same as we all do as people, right? We see a friend, we say hi, how are you? And that friend maybe replies back, okay, I'm good, thank you, and you, blah, 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 right? And what do? We have proved that we can both send and receive to each other, and that is called, therefore, a three-way handshake. Okay, and now that we have already proved that we can send data, we have established now a medium of communication. So now that communication session has been set up and the data can be sent back and forth, and we then see the same as when a person is talking on the phone. For example, you have to acknowledge the other person on the end to keep on letting them know that you're listening so that they can keep on talking. It's the same concept here. So we acknowledge continuously that we are hearing what the other person is saying so that they know we are still there and did not just get disconnected or drop off. So eventually we run out of things to say. So either side can send a FIN packet which signals that I'm finished with then the number. In this case, I chose 3890. Host B gets that and acknowledges, yeah, okay, I see you are done. But host B will then later, when it is processed its data correctly, will send its own FIN packet because it doesn't want host A to leave until it's sure it's got everything organized and structured properly on its end. So then it sends its own FIN packet and resends that acknowledgement to host, to which host A now acknowledges that it got it FIN, and we do what is called a graceful close, and we shut down the communication. So we can see that TCP is a very well-mannered, very structured type of communications, and it is actually one of the ways to ensure network security. So if you do communicate over TCP, it ensures that at least you don't lose any kind of data along the way, right? Data is received as sent without any loss of traffic. So when we move down now to the network layer, this is really the heartbeat of communications. And this is where most of the work happens. At the network layer, we have a number of protocols we use all the time, the most common being the IP, so the internet protocol, but others such as ICMP and IGMP are good, like for broadcasts, for creating group broadcasts. So when we communicate using IP, we have two different versions today, and I know that we are all aware of this, so pardon me if these are things that you already know. So the first version is the IPv4, which has a 32-bit IP address. And so remember, like I said before, network transmission is just a bunch of signals, ones and zeros. So to tell someone like my address, you can reach me through maybe like 1001111, it becomes very monotonous and probably very prone to errors. So instead, we needed a standard to break this large of data. So this is what I was talking about. The moment we achieved this was when the internet went boom, it went ballistics. So in this kind of approach, we break it into octets, and so we could call like things like this here, rather than 1001, maybe to 172, 16.254.2, and each of these 8-bit pieces will represent like a number, like I've demonstrated there, and we'll have a decimal notation. So sharing that is very much, it's easy, efficient. But the problem with this is that we kind of ran out of them, right? So one disclaimer is that IPv4 was built for communication and not for security. So it is very easy to spoof, alter, or even lose traffic on IPv4. And the reason as to why we ran out of them, it is because when you say it is 32 bits, so that means it is 2 to the power 32. So you can guess how many IPv4s we have out there in the world if you do your mathematics correctly. So once again, we had to go back to workshops. We had to put our engineering brains together, and we came up with now a new standard called the IPv6. So this was, we say it is new, but it was developed in the late 90s. So when we were transitioning to the 2000s, and it was developed, of course, to address many of the short fails in IPv4, and it greatly expanded the size of the IP addresses from the 32 bits to now 128 bits, which is a phenomenally huge number. So that means the number of IP addresses available is 2 to the power of 128. And remember, every time like you add like 1 bit, you actually double the number of possible IP addresses. So for example, in the previous IPv4, the one that had that 2-bit addresses, so if it could be like a 33-bit, that will already be twice the size of today's IPv4 addresses by just adding that one single bit there. So back to now the IPv6. So whenever I'm going to send traffic, I put on a header from what we have established in the OSI model. We talked about headers before, right? And we show you what the IPv6 header will look like, right? You see at the top will be the version number. It will show 6. We're gonna be seeing this practically, so don't worry. Yeah, so get excited around that. It will show 6 in there, the traffic class, the flow label, and the payload length, right? And also the next header. So the location of the next header, rather, and the hop limit. So in the IPv4, it wasn't called hop limit. It was called now TTL, time to live, right? So the reason for this is that, so when a packet gets lost on the internet, it doesn't just sail forever looking for a home. So that's why we have like the hop limit. So once it's basically used, it's book of like the tickets run out, and every time it moves from one router to another, it has to use one of these tickets. So it has like a booklet of tickets, and it minuses, yeah, there's a computation around that. So for example, if it goes 30 spaces, then it will actually be dropped if its hop limit is 30. So we like to say that it has run out of gas or money to ride the internet. So that has saved us from the problem of having billions of lost and lonely packets continuously looking like for a place to go, like the evil forces or something. So, and then we do have now like the 128-bit address, so the source address of the person sending the traffic, and now another 128-bit address of the destination, so of the person receiving it. So another thing that was done in the IPv6 address was the development of IPsec, so which is the Internet Protocol Security, and this was to address the weakness of IPv4 of spoofing and alteration of packets. Remember, like I said, IPv4 wasn't really built for security, but rather for fast communication, but not security. So IPv6 was a revolution around that. Yeah. Now we're gonna be looking at the data link layer. So we prepare things to, this is where we prepare things to go over the physical media, right? Whether the physical media is copper or wireless. So this is where you hear things like address resolution protocols, all those things, and also things like protocol like point-to-point protocol. And so that is really that. It just prepares what will go now. Now on the sender's side, remember this is on the sender's side, the data link would prepare the data that will be handled on the physical media, and we do have protocols there. And we have like also, as you can see, if depending on now the nature of the physical media, remember, even if it is wireless, that is still the physical media. So just remember that, guys. So here we can see we have different protocols related to wireless communications, such as the wireless equivalent privacy. We have the Wi-Fi protected access, and then the same 2 and 3, and also some hardware types of encryptions as well. So this is ideally where it will happen, the data link layer. And so when I encrypt the data that I'm sending at the data link level, I am gonna be encrypting everything. As you can see, this frame, I'm gonna be encrypting everything other than now, probably you have just tried the destination address, just to tell that next media or layer what to do with the data. So finally, we're going to be looking at the physical layer, and we said that this is how we actually connect devices together. So it can be wired, wireless, or fiber. So any questions, guys? I do hope you enjoyed the first part of our activity. So see you are right on time. Anyone who has learned at least something, but we're gonna be now visualizing all of these things that we have had. So do we take a break, Licio, or do we just dive right into it?
Since we'll be using Wireshark, we'll take a break when they are downloading Wireshark. Let me just put this link here. Guys, Wireshark is a protocol analyzer that we'll use to go through the ISO model. Kindly download Wireshark as we take a short break.
And so let's just share the resource that.
Yeah, share that in the chat. Wireshark is available for all platforms. So whatever OS you're using, Wireshark is available. Please engage in the chat. Let me know when you've downloaded Wireshark.
So yeah, if you're also on like Kali, you're just good to go. You can just share. And let's just, maybe you can do a survey. Let's see how many people have Kali Linux already installed.
Yeah, how many people are on Linux, Windows, Mac? Just type the OS you're using.
Yeah. We have Victor says Kali. We have Ubuntu. Okay, Linux, Ubuntu. So guys, on Kali, I think you're already good to go. So on Ubuntu, you also have to install it, right?
Let's go to the website and the instructions over there.
Yeah.
So for those on Kali Linux or on Linux basically, but this applies to everyone else, go to this GitHub link and download the TCP handshake pickup. Let me reshare this again. Yeah, that is the TCP handshake pickup file that we are going to be working with. Alex, just allow me to share my screen.
Okay, just a second. There you go.
So you'll just use this button to download on the far right. Then let me know if you downloaded that. Okay, Victor has downloaded that. Anyone else?
Anyone having trouble following up? Anyone lost? Don't feel shy. Yeah, once downloaded, just confirm. So we should continue 11:25. So
Okay,
maybe in 2 minutes. So let's give everybody like 2 minutes. Maybe 5 to set up Wireshark just to get familiar with the environment.
can you see my Wireshark? Okay. And do we have guys on Windows? I haven't seen anyone on Windows.
We have Zipporah.
Okay. Okay. It should work fine.
As long as you have the same data.
So yes.
So maybe you can begin us from how we get to here.
So Wireshark is an open source protocol analyzer to analyze network traffic. So from the pickup that you've seen, pickup stands for packet capture. It's the file format that we use to save network traffic. And in our pickup, we have 3 instances of network traffic. For the first one, we are going to, for this pickup, we are going to go through the TCP handshake, what Alex went through, and now get a real sense of it. So Wireshark, we can use it in home networks. You can use it to play around, just analyze the traffic that you have in your home network. But for this, we can begin with 1. I hope you're following along. Just click on the first packet. This packet is just a part of a larger segment that we use to send data over the internet. So we have the source and the destination, our source being the default gateway. Yes, Alex, I see your hand is raised.
Okay, apologies for spoiling your flow. So ideally, I don't know if anyone managed to get the same as what Licio has on his screen. Anyone who knows how to get to this point? So when you open Wireshark,
okay, I forgot about that part.
Yeah. Okay, yes. Yeah.
So
yeah.
Just go to File, then Open. Then in your downloads, you should see the pickup that you've downloaded. I already started capturing my own traffic, so sorry.
Maybe reopen the application again.
Yeah. Just close Wireshark here. Okay, I have to reshare again, so let me stop sharing, then reshare again. Okay. So you go to File, Open.
Maybe. Okay.
Then look for the pickup file. Is everyone on the same page?
Give a reaction on the chat. Or +1. Like so. Yes, Victor says he's there. Margaret +1. So confirm, guys. You don't want to leave anyone behind. We do have a very shy audience today.
Yeah.
It's okay. Lisa can continue.
Okay, so as I was saying, if you click on the first packet, we have our source, our destination, the protocol that we are using, the size of the packet, the port of the source and the destination. Then if it is a SYN and an ACK, which we are going to do right now. So for the TCP handshake, we start with a SYN. TCP three-way handshake, that is SYN, a SYN and an ACK, and then an ACK, acknowledgement message. So as for the first one, we start with a SYN, where we see the first sequence number is set to 0. That begins the SYN. Or let me just explain down here what you see down here. This is the frame, this is the physical layer. Just in case you're confused by all this, this is the physical layer. It shows that we're using Ethernet. Then we go to the data link layer now, where we see our source destination. So our source is our router. The destination is we can see this is the MAC address of our computer. Okay, the source is the MAC address of our computer. The destination is the default gateway of our router. This is the IP version 6, if I presume. And this has to be the MAC address of our computer. Then we move to the network layer here, where we see the protocol that we are using. It's TCP. Then we go to the transport layer. Let me just minimize this. So here for the TCP, the transport layer is where the TCP handshake goes through. So we see the source port is a TCP port. The destination port is 80. Anyone knows what port 80 is? Or just type it out in the chat if you've any idea of what port 80 is. HTTP, correct. So that is an unsafe protocol, HTTP. We'll go more into that later. But then here's where we see the sequence number 0. That is our SYN message, sequence number of 0. Moving on to the second packet. Once we send it to the server acknowledges with an acknowledgement message of 1. Let me just click in here. I don't know if you can see this. Not yet. Okay. I have to close this down. Okay. For the second one now, the destination is the one that replies, the one starting with 212.58. So we move on to the TCP message down here. Or you can see even from here, even without doing that, acknowledging message equals to 1. Then for the third packet, from our source to destination again, sequence number is 1, acknowledgement message is 1, which completes the TCP handshake. Anyone stuck on any of this? There's more network forensics. So this is just one protocol, the transport protocol. Next, we'll go into DNS. But before that, any questions on this, on how to use Wireshark? Anyone stuck? Yeah, Alex, should we go?
Yeah.
Okay, for the second one, let's move on to the DNS.
Maybe before before you exit, let's go to the IP header just there.
Okay. Just a second.
There's something we missed to see. Yes.
Just let me.
We have the Internet Protocol version 4. So you can see that this is an IPv4. So that is where you get, like, when you see 4, it means it is IPv4. So, and you can clearly see the source address. It is an IP address of IPv4. So if it was 6, then you will have to see like a source address of IPv6 and a destination address of IPv6. So yeah.
Another thing you can tell is just by looking. This numbers 172.16, those are IP version 4. The IP version 6 are separated by colons, double columns. Yeah, also by looking, you can tell if it's IP version 4 or IP version 6.
Yeah, we also have like a TTL there, time to leave 128 hops. So it means when it exhausts that, the packet will be dropped automatically. So that means it goes after every router it goes through. Before it reaches its destination, it minuses a one. So maybe things to also consider when designing your network. Yeah, so good stuff.
The next is DNS. The link that I've shared, I believe it's here. Just stop sharing for a while. So our next pickup, you're going to do the DNS. So download that pickup file. And let me know once you've downloaded and opened it in Wireshark. Guys, let's engage in the chat. Okay, we have a good number who've completed. So this lab is for the DNS domain name service. These are relatively websites. We call domain names are translated into IP addresses through network address translation. So if you go to a website, this website 4.2.2.1, it will lead to the website that we are going to find out later. So for the first bucket, let's inspect that. So DNS is normally in the application layer. So it will mainly be focused down here. And it uses for a UDP. UDP is let me say, unreliable protocol because it is not as reliable as TCP since it drops packets. So things like Zoom, this is UDP, it uses UDP since it is okay with dropping packets. It just focuses on delivering packets, not that they acknowledge that they've reached there. So let's check this out. I think for now, you know how to check the source and destination. Anyone with any problems on checking the source and destination? And the DNS port is 53. That's another topic for another day, port numbers. But the DNS port is 53, and the destination port is another, it's a UDP port, 57434. So there are about 65,000 ports that are available. Most of them are TCP and UDP. For this one is a random UDP port, 57434. Here we can check that. Just a second. Timestamps. The main focus here is the domain name system. So this user was going to espn.com. As you can see here. So CNAME is just canonical name, an alias for ESPN. So this user was probably streaming a match in ESPN. That's why it uses TCP. For streaming, it's also UDP. So this user was probably streaming a match in ESPN. So we'll go deeper into this once we get to the terminal and use some commands to check for DNS records. That will be an exciting session to look forward to. So this is the IP address of this server, 68.71.212.158. Okay, Charles, you say you got lost. Where did you get lost? You can just type it out or just feel free to unmute yourself. Have you downloaded the pickup file, the DNS one?
Actually, I got lost due to my network ups and down.
Okay.
I'm not able to know how we got into the DNS means domain.
Domain name.
I'm not yes. I'm not able to know how we got here, but I'm following since.
Okay. Is the link still visible? The link to download the pickup file on your chat? Or you lost that too?
Let me check it.
Let me just reshare this again. It's a private message, sorry. Let me put it down here, okay. There it is. Guys, Wireshark is a powerful tool. You can use it to scan your own network and see for DNS, like what sites you visit, the IP addresses, Alex, go ahead.
Maybe to add on to that, how is this DNS scanning useful in maintaining like acceptable user policy? Because I can see that we are able to see where different traffic was going through, like in terms of the different sites people were seeing. So is it one way of maintaining an acceptable user policy or ensuring that we maintain that?
For this, probably if you're using a VPN, that will be blocked. You can't see this. You'll just be seeing gibberish. Yeah.
So we can't get the VPN traffic through this, right?
VPN traffic is encrypted.
So, okay, yeah.
It will bounce to multiple servers, so you can't get it. But if it's unencrypted, you can get this.
Oh, okay, awesome. Good things to know. Anyone else with a question? Questions are always good. And there is really no damn question. I've never had a damn question ever in my life. So feel free to ask.
This is part of something called reconnaissance, where you, let me say, stalk your target. This is where it begins. For you to attack, or you're doing penetration testing on a server, you have to know its IP address. This is where you start. I don't want you seeing my IP address. But we'll get into the terminal real soon once we are done with this. After this, we'll give you a challenge, a simple one on HTTP.
Later, I think everybody should share their own IP addresses so that we can reach out to each other rather than phone numbers. So guys.
Your home now?
Zipporah, we can hear you. Okay. Yeah.
Okay, Charles, can we go now?
Yes, we go on.
Okay. So right here, we just clicked on the first packet. And we were looking for the DNS. This is clearly laid out because Wireshark is a good tool. It's a GUI as opposed to going to the terminal. So you go straight to the domain name system here. And here in the queries, you can see the user was heading to espn.com. And the fact that this is UDP, this is probably streaming. Streaming uses UDP as opposed to TCP. So here for the domain name records, we'll go deeper into domain name system once we get to the terminal. There are things like the type A address in the DNS records, type C, the canonical name. This is the canonical name stands for an alias. This is still espn.com. That's why you can go to www.espn.com. Will redirect to the same thing as you go to directly to espn.com without putting the www. So canonical name. Then here's another canonical name. Starts with redirect, REDIR. This is the name of the server that he was streaming on.
So, Alicia, we do have a question on the chat.
Okay.
Yeah, they believe it's LAT. Wow. LAT,
okay.
Yeah. I have a question.
Yes. Hello, guys.
Hi.
You can get me, right?
Yes.
Okay, I have a question here. Like
Mhm.
the IP address I'm seeing here is 170 something. So we're trying to check out what that person has been doing, right?
172 is a private IP address. So
Yes, yeah.
it's probably checking their own IP, their own network.
Their own network. So for example, if I put my own IP address here, then it will show me what have been my history that have been searching on my internet, all these things.
Once you hit what is this button called? Is it record or the big red button there on the
Yes.
top left? It will start recording traffic. Then you can hit stop. Then save that in a pickup file and begin investigating.
Okay, so it will only record on the network that you're connected.
Yes.
Okay, so the network that you are that you are connected to, it will show the people who have logged in, the IP addresses of the people who have logged in into that network. So you start now investigating what they have been doing according to. Right? Am I on the right?
For home networks, that
Yes.
everything goes through the router. So you'll be basically just doing investigating your default gateway, which is your router.
It's okay. Yeah, I wanted to
but
find,
not individual.
I do get what he's trying to say. He's trying to say, like, for example, you are on a corporate network, right? And you check your Wireshark. Will you get the traffic for all the other users connected to the same network as you?
No.
Very true. That's what I meant.
Okay. No, you will get for your own device.
Or only the traffic coming in and out of your own
device,
network interface card. So basically, yes. Okay. Oh, interesting. Good question.
Yeah. So that's what I meant. The other question is, now, after now getting the traffic that you've been interacting with, will you get any bad information that try to attack you, or anything, any misinformation or a link that you went in by mistake? Like, will it show any kind of threads?
Yes.
That you have.
So once you hit that packet capture,
links.
Once you hit that packet capture and begin, maybe go to your browser and start doing stuff.
Yes.
It will record everything that passing through your network interface card through to your default gateway, everything. So all the IP addresses, unless you're using a VPN, then that would be a bit.
Simply, it's like you're pen testing. Where did you go wrong? If your system had an issue, or if your network had an issue, or maybe you were blocked out. So you will have to come and now trace back using it.
Yes.
Where did you go?
Exactly. So Wireshark records all network traffic once you hit packet capture.
So the use of a Wireshark is to collect the information, or is to do an investigation for a certain session that you had done before.
Yes. So these are all. Once you get deeper into cybersecurity, Wireshark is incorporated into something called a SIEM, Security Investigation and Events Management, which records network traffic and now gives an incident, those alerts in case of an attack. But this is incorporated right into a SIEM. So you don't have to do it manually unless you're just testing your own network.
It's okay. So testing your own network, is it bad to test other people's network?
No. Since you'll be using your own device, so you'll be testing your own traffic.
Okay. Thank you.
Let me see. I see another question in the chat. Exposes the IP address. Which IP address that is? Joe, your own IP address? Because that will be, that is not appropriate to expose your IP address. We don't recommend that. You'll be vulnerable to attack. Other people connected to your network Then you'll have to log into your router to see people connected to your network. If probably you're using Safaricom, you can log in to your router and see the devices and their IP addresses. That's how things like your internet service provider, that's how Safaricom tracks the websites that you use, even Google. So they can rank websites according to maybe the most common. That's how they do it. These are DNS records linked to IP addresses. Wireshark, you're testing your own device, unless you install Wireshark on that device as well.
Yes. So what happens if you are connected to a network, maybe a public network, that in your device it says it's not secured, but you are connected but not secured? What happens? Can this somebody read your information from your device? If in any case he enters into the secured information, now that you're connected and not secured?
They cannot read whatever you're doing, but they can spoof your network. That is, see your network traffic if the network is not secure. That's why we advocate for WPA3 if you're on a wireless network, and not WEP, which is a more older version. So WPA2 PSK, that is pre-shared key, we recommend that on your home networks. Don't use an open, like a public network. It is easily spoofed. That's why you're told not to go to connect to airport Wi-Fi traffic or Wi-Fi networks, unless you use a VPN. They can spoof your network.
Yeah, good questions, guys. Very interesting ones.
So let's give this guy a challenge, which we'll come back to it later on the HTTP one.
Yeah.
Let me just share the link on the HTTP in the chat.
Sasha, you still on the call?
Yes, I am.
Yeah, so we're planning to have a challenge, and I don't know how we're gonna reward the winner. Maybe you can brainstorm around that and tell us later.
Yeah, I'll tell you later. My neck on the spot.
Right. Pole. Na pia nilikuwa nashangaa, it's good to reward hard work. Yeah, so Victor says a scholarship. Maybe for the first 2 days, utalipa school fees. Class for free. Anyway, so the rules are as follows for this next challenge, but I'd like Licio to briefly explain them for us.
For this challenge, let me just put in what I'm looking for. Just a second, the source IP. Destination, those are the easy ones. This is first come, first serve. Whoever responds to that pickup, then email, website, email, and then the post message. Yes, those things are what I'm looking for in that order: source IP address, destination IP address, the email address, the website, and the message that was in the post.
So you download the pickup file through the link that Licio has shared. Open it on Wireshark, and from there, get to investigating. See if you manage to get the source IP address, destination. Then finally, two things: email, website, and then the post message. So,
will you give them some time, or can we go on?
I don't know. Let's see. We still have time, so let's give them like 10 minutes, right? Alafu we come and do the final part, right?
Yeah.
So 10 to 20 minutes. So
Yeah.
Sasha, if you don't mind, you can play some music.
I have to share my screen for me to do that.
This you.
Okay.
So Valentino, we're investigating the HTTP pickup.
All right.
I'm just answering a question from Valentino here.
Okay.
So we are investigating the HTTP pickup, and then reply with the source IP address, destination IP address, the email, the website, and the post message in the chat. First come, first served. Go on, Sasha.
took this time than expected, actually. So congratulations to some of our experienced network engineers in the class. Lucy, did you get it right? Or
Yes, in the order that I put in: source IP address, destination IP address, email, website, and the post message. From that, the first person to answer everything is let me check it out.
Brian?
No, actually it's George.
Uh,
He had missed out the
Oh.
post message, then he had put it in. Some of you forgot about the post. Yeah, so congratulations to George.
Maybe George would like to show us how he did it. Maybe we learn. If George, you don't mind, you can share your screen. Does he have permissions to do that? It's actually volunteer basis. I'm not putting you on the spot. You can choose not to, but ideally it will be very exciting to see someone new talk to us today.
Well, on my screen, I can see I'm not allowed to share the screen.
Maybe Licio can present and George can walk us through.
Okay.
Yeah.
Just a second. Yes, George.
Also, you can chip in the rest who got the answer right. Everybody is free to contribute on this section.
The shortcut I forgot to show them. We could have done it so much easily. Or should I continue?
Let's first have George show us how he did it, and then you can show us the shortcut if it is not the same as George, hopefully. But inaonekana itakuwa. Go ahead, George. The floor is yours whenever you're ready.
Okay, I'm ready. So what I did is, it was specified we need to test HTTP. So I clicked on HTTP, which is on the number 4. Then on I went down to where the frame Ethernet and the sort are aligned, and clicked directly to the HTML form first. The HTML form URL encoded. That's where I clicked first. So I was able to capture the email, the website, and the URL. And then above the hypertext, the transmission protocol, sorry. That's where I saw the internet protocol version. The source was stated there and the destination. So I just took everything, the source, the destination, and then I went down to HTML form URL encoded, took the email URL and comment. Comment was the message. I had forgot it out. So I went.
No, I had not put it in. I just put the post message.
Oh, yeah. I just realized after I had posted.
So good job. So another way you can do is right click on this and then follow the TCP stream here. So here you can see the author, Chris Sanders, from this line. So this is all visible if you're on an unsecure network and using HTTP and not HTTPS. So when you submit a form, this can be captured. Because this is HTTP, it is an unsecure protocol. That's why we use HTTPS. You can get post responses if you're using HTTP. Yeah. But now what I want to get into is just a second here. A bit of commands. So a bit of commands you should be familiar with in networking. The first one is ping. I don't know if guys you know what ping is. Ping uses the ICMP protocol that we learned in when Alex was presenting, the transport layer. So this works on either on all platforms, Windows and Linux. So for Windows users, you can go to the command prompt, just type CMD and press enter. Linux users, you can go to the terminal. I hope you have your terminals open. Just text done when you do in the chat. The Brian is done. More responses.
Still have Charles completing the good initiative from Charles. Thank you. So if you're on Ubuntu too, don't worry. When we say Linux, we actually mean Unix. So macOS, Linux, Ubuntu, all those are good to go. Windows to open the command prompt.
Command prompt will still work with this command. Okay. The first command we are going to do is ping. PING. And there's a couple of options you can use since ping will not cut out. So I'm going to put a count of 5. And we are going to ping, let's ping which website? Let's ping moringaschool.com. So this is just checking if the server is online. Wait, just a second. Let me do this again. Let me try with Google, my virtual box. Okay, let me check my network settings a bit. Just a second. Apologies for that, guys.
Yeah, it works, but on VM, it depends on if you have maybe a bridge adapter or just but your network adapter is out or something.
Yeah. It seems my I have to restart this.
So let me just okay. So until this is ready. So guys, I'm not on a VM myself. PC you can use your actual the macOS terminal. It has all the other features, right?
Yeah, I'm still on Windows, so I can also use. I forgot I had my Windows down here.
Okay. So just confirm that you can see my screen, guys. So ideally, Lisio begins with something called reconnaissance. So there are two parts to this. We have an active reconnaissance and a passive recon. So a passive recon, this is whereby you're just observing your target from a distance, right? Getting to note all the angles, see the vulnerabilities from afar off without actually now interacting with the target directly. So ideally, during this time, you have access to a bunch of tools, and research is very crucial. So there's no really one direction to go. Like there's no specific, like you have to follow this strategy. It's just utilizing the resources that you have available. And the first step to do is to probe the network or the server, or if it is a web server, in that case, an email server or a HTTP server. And we have access to a bunch of tools that tell us a bunch of information concerning this. So on your terminal, you have access to commands, pre-built command. Others you have to install them. And before working with any command in the terminal, ideally, the first thing is to check what that command does. So you can do that by using the man command and now the name of the command. So we can see the ping command says it sends an ICMP echo request to network hosts. So that means we can utilize that feature and check if this network is connected, if it is up and running, and all those stuff, right? So the most common way to do that, you can maybe use the Google DNS. So remember, this is a DNS server we are probing. So it is a web server via DNS services. So let's see. We see it is up. So ideally, you get like the number of packets that were transmitted, the time it took to transmit all the 5 packets. So, and if any packet was dropped along the way. So we have 5 packets transmitted, and the same packets that were transmitted, which means they were received. So no packet was dropped, meaning that our server is up and running. Yeah. So in this command, the same command ping, you can use the man command to check now extra information around this. We have extra tags for different functionalities, like the one we said. The C tag prohibit the socket from using the cellular network interface, and it is
Use the small c.
We use the small c. Okay,
Yeah.
I'll count. So it says stop after sending and receiving. So it counts the echo response packets. So if this option is not specified, ping will operate until interrupted. So we can maybe check that actually. It will run like until we stop it now on our own. So we don't, not only do we have more packets going through, we have extra packets until now. We type like Control-C and close it. So that is one difference. We can't get to all of those commands and all the tags, all the helper tags for a specific command. But ideally, if you know what you're working with, you can research around the man pages to tweak your solution. So Lisa, I hope you are set up.
Just a second. I had to restart my VM again.
Okay, no worries. Any questions around this? Anyone with an interesting server we can look at? Maybe your IP address you can give us and we ping you. What is it called? There's a type of attack associated with this specific command. Anyone who knows what that attack is called? Where you change the packet, the size of the ICMP packet, and it is large than what it is supposed to be. Maybe just research around that.
I think I'm all fixed.
Okay. Yeah. Let me just stop sharing.
Let me just like this.
Yeah, so it is called the ping of death. It's like a denial of service, some denial of service type of attack. Sarah says access denied. Using Windows. Oh, you need to close the command prompt and open it as administrator. Just close it, and now when you run it as administrator. Yeah.
Okay, I hope you can see my screen.
Sure.
The next command is DIG. It stands for Domain Information Grouper. It's a powerful tool for querying DNS records. So you can see who registered the website, which web servers they are, the mail exchange servers. So we'll take a look into that. So to ensure that DIG is installed, you just do div-v on your terminal. Just ensure that DIG is installed. And I don't think DIG is available for Windows yet. So I believe it is. No, that is for Linux, that is. But DIG is not available for Windows, but we have a GUI that will take you through. So let's find for let's check for the DNS servers for Google. So you see in the A records, it's google.com. When it was registered, and we can also check for the CNAME. Let's do a familiar one. Which website do you propose, guys? Google is too common.
Moringa School.
Okay, let's check for Moringa School. Oh, sorry. Here we see the IP address of Moringa School server. This is public knowledge, so it's all available. Let's check for the CNAME. There's something called a canonical name in DNS records. Let's check for this. CNAME, moringaschool.com. it is one very long canonical name. Authority section. CNAME, that is blank. It is blank in the DNS records. So if you don't put that in, it will show blank. Any other website you want us to look at? Just put it in chat. ARA. Is it J? Okay, let's do okay, people want to, let's check at KRA. Is it .g or .ke? Okay. It uses MTN business. So the IP address is here. CID. worldwidewonderer.com. Okay. Let's do a big wide wanderer. It's Bluehost. Okay. Alex. CID. 0. You guys are really poking at the government. They hosted at Treasury. Okay. Another thing is NS lookup. So it gets the IP address of a website. So do NS lookup. It's similar to dig. Then let's do Moringa School.com. NS lookup just stands for name service lookup. So Moringa School, the name, the IP address. This is the MAC address, not the MAC address, the IP version 6 address. Looks like this. Joe, now you see why you see the CID website is hosted on Treasure.
I was shocked to see that too, Joy.
Okay. Let's scroll over to another NS lookup. Let's check which one. The mail exchange records to see which name servers that Moringa School uses. So the NS lookup. Then the flags that we use for this, you can use type equals to MX. That's for mail exchange servers. Then your target, moringaschool.com. Takes a while. Connection timed out, so let me do this again. Servers cannot be reached. Moringa's firewall has kicked me out. Okay, let me just close that. Let's look at which one. Yeah, they. Is acting up again. Okay, just a second. I see the problem here. I forgot to add in this. Yeah. I forgot to add in the dash, the hyphen. So MailX, the Moringa School servers are here.
Maybe to interrupt you for a minute, So what Lisa is doing, where we have the type MX, so we do have other different types. You can research around this. They are called they're known as query types. So
yeah,
each indicates a different thing that you are looking for. So the MX is for the mail exchanger. We have the AAA for IPv6. And we also do have others here.
yeah. This is for basically G Suite, the mail servers that are for G Suite. So we look at the name servers. It's Kenya Web Experts. These are the name servers, and S stands for name servers. So if you want to know where our website is hosted, you can just look at, you can just use this command. And once again, all this is public knowledge. It's all just for you to look for them. If you want to look for any, like all the records, just do this and type is any.
I want to respond to that question, Alicia.
Which no, okay. No. Those are just public IP addresses on your home network. So that is my default gateway, my router IP addresses. I think all IP addresses in your routers start with 192.168.100.1. That is the IP address of my router, of which is common for all routers. It starts as 192.168.100.1. That is it's public. It's a public IP address. Private is 172. And 10 dot something, that is a private IP address also.
Awesome. So yeah, really the search engine is your friend, guys. So when you get something that you're really not sure, just research around. Like IP addresses are not, they're unique identifiers, not limited to geographical locations, right? So each subcategory means things differently. Like we have a scope of IP addresses that are only defined private addresses and others that are public addresses. So you might get lucky while doing this NS lookup dig thing and land on a private IP address, and this is really where the money is. So yeah, that is the whole essence of this, getting to see what are the breadcrumbs that are there that you can leverage and escalate your attack, or at least plot a scenario of an attack.
To respond to your question, Joe, your phone's IP is your router assigns your IP address. Basically, your router gives out IP addresses to the various phones and devices that you have on your home network. When using mobile data, that is your ISP. Your ISP provides your IP address. Basically, it's Airtel provides your IP address, since you're connecting to their network.
So Joe, you can research something called voice over IP. Yes. And get to see how SIM cards are now translated to IP addresses, like the number that you have when you make a cell phone call or something. It is just gonna be translated. At the end of it all, it's just gonna be an IP address. Just know that. Okay. Depending over the phone call, over the mobile data. Now, when you're accessing now like a Wi-Fi, now that is not mobile data, that is now a wireless access point you're using to access the internet. And most people think that the internet is wireless. The internet is not wireless, guys. So it is not. What is wireless is the different things that you have on your devices that enables you to have like a wireless communication. I hope that kind of sinks in. You see, we are running out of time this year, but
yeah. Let's do one more. Called Who Is.
Yes.
Who Is is just a listing of the ownership of domains. So if you want to know who owns a certain website, you use this command. It's just called whois. And meanwhile, Alex, you can put in the chat the GUI versions of what we've done so far.
Okay, for sure, for sure.
So if you want to check whois, you can mask whois by paying an extra service. Most hosting providers do this. You add an extra charge to hide your information. So, but if you haven't paid for that, that is publicly available. So if we check for whois moringaschool.com, here we see, yes, all this information. So this is like a public database of all registries of the website, provided by ICANN, the Internet Corporation of Assigned Names and Numbers. So if you want to register a website, it has to be through that database. So these are the
Hello. A question, please. Before.
For sure.
Yes. Our question.
Go ahead. Go ahead.
From the studies, can I still know the host of my domain?
Yes, that is what we have been doing with DNS, the NS lookup. That is the host provider. You've seen Moringa School, Kenya Web Experts, all that. That is NS lookup.
So for NS lookup, let me just share a GUI tool for that. The one I've shared is comprehensive, so use that one. And the second one, you can just put in any domain name there, and you will find the DNS records for that.
So let's look at KRA. Use your tax mode. So KRA is Kenik. What does Kenik stand for? I forgot again. Something. So the whois server is from Kenik.
Oh.
The host MTN business.
So
Victor, you said you tried it web.
Kenik is the Communications Commission of Kenya.
Yeah.
So, and
Kenik is it's basically the ones who provide the .ke domain.
Yeah, for a lot of the organizations out here. So if this goes down, you can imagine the impact on.
Yeah. So you can install whois. Does it? I'm sure Ubuntu gives you a prompt if whois is not installed. Sudo apt install whois. For Windows, you can use whois. Have you posted the link for whois?
Okay. I believe.
Just see. I think I have it here.
Okay.
Let me just post it in chat. So that is a GUI version of whois. Basically the same thing you see on your terminal, but more in a web version.
So just a second. I think you've pasted to an individual person.
Okay. Oh, sorry. Sorry. Okay. Okay. I see.
Yeah.
Oh yeah. So there are a lot of commands out there just for networking, things like nmap for network mapping to check for open ports, and which other one? Traceroute to check for the hops, how your data travels from one router to another. Then which other one? Which other have I forgotten? It's Traceroute for Linux and Traceat for Windows. Let's check this command pages. Yeah, printed out packets trace to the network host. So if you need help with the command, just as Alex mentioned before, use something called the man pages. Put man and then the name of the command that you want to learn about. So it's like a manual or a documentation of how to use that command and all the options that are associated with that command. Just press Q to exit. And I think that concludes our session for today. Questions?
Yeah. Very awesome. Very engaging session.
This was recorded, Joe?
Yes, the session is recorded. We'll share it on Monday. So just check your emails. All right. Thank you so much, Alicia and Alex. I don't know if you guys still have any questions for our facilitators today, or rather directed to our facilitators today before we come to the end of our webinar. Any questions? Okay.
Mine is just to appreciate. I'm able now to know the host of my domain. I'm able to read the details. I'm able to access the information. I'm good. Thank you, Moringa, for this occasion.
Nice. Thank you so much, Charles, for those remarks. We truly appreciate it. Okay, so for those who are curious, where where can I learn all this? Maybe you've just been in the background, and you're wondering like, what next for me? I really want to become a cybersecurity specialist. We do have programs. The cybersecurity prep that you can see there on your screen is for complete beginners. So let's say you've just completed, or rather you're even still pursuing your degree or diploma in uni or college, and you're trying to find a niche, or you're in an IT field, you want to completely, change. So you can start with the prep course for complete beginners. It has like introductory material. I'll ask Alex, please share the link to the website. I can't switch between my screen. If you can just share the link on the chat box to our website. So you can just go there, download the brochure, see what is covered during the prep week course. It is a 12 weeks program, part-time, that runs from 6 p.m. to 9 p.m. during the weekdays. Yeah, so just go to the link there, moringaschool.com, then click courses, go to cybersecurity prep, check out all the details there around like what is covered, what you will learn, and the outcomes of the course. So the prep course is 35,000 Kenyan shillings, and we have an intake on August 28th that's starting. So you can take advantage of that. And then cybersecurity bootcamp finally. So this one is a more extensive course, okay? So this one is going to be a full-time program, right? And it's running for 18 weeks. So this one is more extensive. You're not just going to learn the fundamentals, but you'll be able to specialize and come out as a cybersecurity analyst. So more details around that are gonna come soon. From the 1st of August, we'll be launching the course. Then the classes will start on September 25th. So if at all you fall under either categories, I'll be sharing, oh gosh, I hope you guys are not seeing my screen. I'll be sharing a feedback form in a few that I'm going to request you to fill in your details. And then you let us know which program you will be interested in. So we'll reach out to you next week once you've told us there which one you're more interested in, which one suits your profile, and then we'll be able to now just take you through the admissions process. So you can see that the requirements to join our programs are pretty simple, not that hard. So as long as you have fundamental computer skills, you're able to sign up for the cybersecurity prep and start from there. Then we always do like an assessment test so that like we are making sure that you're the right fit for the program. So don't shy away from that, attempt it. You see, like the way today you guys have been very interactive with our instructors. It's the same thing, just try, and if you score above 40%, then you'll qualify to join our courses. We also don't provide laptops, and since most of our programs are running online because people are everywhere, we encourage you to have a really good laptop with those specifications and have access to stable internet. Our mode of communication at Moringa is also 100% English. So we also require you to be proficient in communicating written and verbal in English, and then make sure you attend all classes so that you qualify for the certificate at the end of the program. So something I forgot to mention, in our cybersecurity prep course, the beauty is you're not just gonna learn the theory, you'll have a lot of practicals and lab works that is done. And then right now we have, we are collaborating with ISC Squared. So you'll see that once you go through the training, you're also gonna be prepared to take on the exams for an ISC Squared cybersecurity beginners certification, which is globally recognized, right? And then for the bootcamp, this one we're offering CompTIA Security Plus certification. So when you join either of the programs, you see that we've prepared you even to just get into the industry with the right certificates that are recognized by employers all over the world, okay? So, and something else to note, I don't think there's any other program that is doing the most like what we are doing here at Moringa. So take advantage. You have instructors who are really qualified. They are also certified by CompTIA. They are cybersecurity specialists in their own regard. And then we are also preparing you for all the certification levels. So take advantage of it. I'm seeing questions coming in. So can we be having more of these workshops? Yes, we will be offering free workshops once in a while. But if you'd like more in-depth content and training, sign up for the courses, okay? And Moringa should host a CTF soon. Yes, Capture the Flag challenge is coming up soon. Follow us on social media at Moringa School, where we'll be releasing the details and awesome awards, discounts that are going to be offered in terms of like prices, like money discounts for those ones to join our program on the first week of August. So follow us on social media so that you can get more details around that CTF challenge. Joy is asking, how can I reach out to today's presenters? I'll ask Licio and Alex to share their details on the chat box. Maybe an email or your LinkedIn profile where people can reach out to you. Okay. George is asking, which ISC Squared certificate is done in the cybersecurity prep? Alex, would you just help me clarify which certificates are done at prep and at bootcamp? Again.
I think Licio is more qualified to take this.
Okay.
For the prep course, it's certified in cybersecurity, abbreviated as CC. And for the bootcamp, we'll be going through Security Plus by CompTIA.
Okay, thank you, Lucio. George, I hope we've answered your question. So these are the outcomes of going through our programs. You'll be able to explore quite a number of career pathways once you've gone through our cybersecurity training. How to apply, very simple, just the link that we had shared earlier. Once you go through it, you do the test, and then there are prompts that are guiding you at every stage. Our payment methods are also quite simple. So installments only apply for the bootcamp. Prep, we require upfront payment, okay? We require you to pay the full 35,000 before the start of class. And then for the bootcamp, because it's a bit more expensive, we allow installments, so you can pay with up to 4 installments. And then for both options, either prep or bootcamp, you can apply for a student loan with one of our partners called Aspira. We encourage you to start this early so that you can get your funds early enough. And the interest rate is very, very, very low. It's close to non-existent. Yeah. So you can try it out. If at all you don't have the full amount and you need some financial help, just go through admissions process first, and then our admissions representatives will be able to share with you the documentation and all that is required for you to get a student loan and how you can pay it back. All right. So yeah, these are the next intake dates. Yeah.
Maybe to interrupt you, we have a question from George. He's asking the kind of content offered for the ICSC. So like Sasha began the session, she said that we are in partnership with Flatiron School. So this is a worldwide recognized institution. So the cybersecurity prep bootcamp, we are using their content. So it is pretty top-notch content. And we also do have like other practicals for that. And then now, given that the CC certification is free for everyone, we're gonna be, yes, recommending you guys to take that. I hope that answers the question.
Okay.
Awesome.
All right. So I'm sorry, I'm just trying to rush through so that we are on time and just respect your time. So please take note of the upcoming intakes. We only have one intake for the cybersecurity bootcamp. So take advantage, and we have very limited slots. It's going to be a very, very lean class because of how in-depth cybersecurity is. So we have like less than 30 spots. So take advantage of the time now, and fill in the feedback form so that you let us know if you're interested in joining, so that we can just keep the spot open for those who have joined this workshop and they are gonna sign up for it. For the prep class, we have an intake on August 28th. So again, also, very few slots are remaining. So please go ahead and sign up and just, book your slot as well. Yeah, so I've been sharing the feedback form on the chat box. We're also gonna send you an email so that you can just let us know how you found this event. Share your comments, your remarks to our facilitators. They'll be reading them. If you have any other questions for us, maybe we can follow up later. We are also asking you to fill all that up on the chat box, on the feedback form rather. Yeah. So for those who are asking for the recording and maybe some resources, extra resources, look out for your emails next week. We'll be sharing a recap of everything that was covered here today. All right. So I just want to leave room for maybe one more person. If you have a really, really burning question, you can just ask before we end the workshop today. Anyone with a burning question? Okay. If there is none, maybe one person can give the closing remarks. I know one person had already shared, but maybe we can hear from another one. Can I pick on? Oh, she already dropped. Okay, one person who'd just like to share like a thank you note to the facilitators and the organizers for this webinar today. Yeah, and then we end the webinar. One person, let's hear from you. David, any closing remarks?
Can you hear me?
Yes.
Okay. I would just like to say thank you from the facilitators. I did B18 campus, but never really capitalized from the cybersecurity side of things, networking side of things. Yeah, so it was just interesting to kind of kindle, and so thank you for this opportunity.
Okay, nice. All right, thank you so much also to you guys who joined and stayed on until the end. This has been really awesome. We're looking forward to seeing you guys in our classes and even in the future workshops, hackathons, and challenges that we will be rolling out. Yeah, so in case of anything, feel free to reach out to us on admissions@moringaschool.com and or on any of our social media platforms at Moringa School, and we'll be able to assist you. All right. So thank you, Lisa and Alex. You guys have a great weekend.
You too, Sasha. Thank you.
Thank you very much.